Let's take a look at exercise 2 for week 11, array demo 2. In this exercise, we're creating the array just a little bit differently. We're taking a look at how we process arrays as arguments to methods, and I have even added um, an extra method into the program that I'm going to review with you that might be very helpful when it comes time to doing your homework, when you're doing the homework assignment for this lesson. Let's take a quick look at this program. I'm just going to go over it very generally before we step through it. So taking a look, first of all, we're creating our array just a little bit differently. It is still called lists. It is still an array of integers. But this time, instead of specifying the number of items and then loading it, I am creating the array with the items that I want. That means that when I take a look at this array, after this line executes, the first item in the array will be 8, the second item 22, the third item 17, the fourth item 24, and the fifth item 15. The only thing I want you to keep in mind if you do this, once you do this, the size of the array is set. We can't make it bigger or smaller. So I just want you to be aware of that. Next, we're calling display array. And if you look at the method header for display array, notice that we have told Java we are to expect this method to receive a list of integers that will be accessible through the variable n rather than just a single integer. Then we're going to print out the string, the sum of the elements, the sum of the array elements equals, excuse me, and we're going to call the calculate sum method, which again has been set up to take an array of integers rather than a single integer. And again, here we're calling it n. Remember that arrays are passed by reference, not by value. What this means to us is that anytime we work with an array, we're always working with the original data. We're never working with a copy. Finally, I have added a method in here called findMe. And this is a sequential searching method, which is one of the useful algorithms that we've talked about in class, or that we talked about in the discussion. And I'll walk you through how this sort of works. Basically what we're doing, we're starting at the beginning of the list. We're checking every item up to and including the last item in the list. So in our case, we're going from index 0 to less than 5, which is 4. And what we're doing is we're asking the question, is the value that we're looking for located in the current location? If it is, we're setting a flag that we've set up called found to true, and we're using this little new word called break. Break is a way for us to exit a loop. So in this case, I'm asking the question, is the item that I'm looking for in the current location, located in the current location of the list? Is it stored in the current location of the list? If the answer to that question is no, then we just keep right on moving on. However, if we do happen to find the item, if this statement becomes true, a couple of things are going to happen. Our found flag is going to be set to true, and we're going to break out of the loop. So either we're going to find the item, or in a sequential search, your possibilities are you find the item you're looking for, or you hit the end of the loop, or end of the list, or array. When that happens, this if statement is going to execute. And basically all we're doing is saying, did we find it? If we found it, then let's print out that we found it and where we found it. Otherwise, if we didn't find it, then let's let people know we didn't find it. Relatively simple. Let's see how this stuff works in real life. I'm going to set some breakpoints here just so we can monitor through our arrays, or monitor our progress through the program and watch how our arrays execute. All right, so let's go ahead and run this program. The first thing we do is set up our array, and then we call display array and provide it the list so that it prints out um, the list of items. And we can look at our list, and just so you can see, again, the first item is 8, 22, 17, 24, and 15, just like we listed them up here. As we're going through, we're going to print out each item. So I is currently 0. 0 is less than 5. So we're going to display the item located at n sub 0. We're going to do this again for 1 because 1 is less than 5. So we're going to display the value located at index 1. We're going to do the same for index 2, the same for index 3, the same for index 4. Again, 4 is less than 5, so we're going to display index 4. 5 is not less than 5, so we're going to exit the loop, and this method is over, so we move on to the next line, which prints out this and calls create or calculate sum. Now, for calculate sum, I did things a little differently. I did not use a full for loop. I just used I used the enhanced for loop, and the reason that I did that is because in order to calculate the sum, all I need is the value of the item currently stored at the current location in the list. I really don't need to know which index we're on. So the enhanced for loop works great here, and simply I'm going to get the first item, which is 8, and I'm going to add it to total, and then I'm going to add 22 to total, and then I'm going to add 17 to total, and then I'm going to add 24 to total, and then I'm going to add 15 to total, for a grand total of 86. Finally, we're looking at find me. And for find me, when I wrote the method, I asked for 2 parameters. A list of integers and the value that I'm looking for. Well, I'm looking for 17, and we know we're going to find 17 in the list. So I start looking at index 0, right? Is the value at index 0 the same as 17? Well, that value is 8. Is 8 the same as 17? No. So we keep looking. Now we're on to index 1. Is 22 the same as 17? No. So we keep looking. We move on to the next item. Well, now we're at index 2. And index 2 is 17. And the item that I'm looking for is 17. Are they the same? And that is true. Let me throw a couple extra breakpoints in here. So I'm going to set my found flag to true, and I'm going to break so I leave the loop. And now I come down here into my test. Did I find it? Yes. So let's display the statement that says, hey, I found it. And give me 1 second here. Here we go. And the value 17 was found at location 2. Now I'm going to ask again for location 44, or for value 44. So let's take a look at our list again. So we're starting off at 0. Is the value 44 stored at location 0? Value there is 8. So 8 and 44, not the same. We're going to look at index 1 now. Is the value stored at index 1 the same as 44? No. 22 and 44 aren't the same. If we look at the value stored at location 2, that's 17 and 44. They are also not the same. So let's take a look at index 3. Is 44 and 24 the same? We're getting closer, but no. Finally, we're going to look at index 4. Is 15 and 44 the same? No, it's not. When we increment I again, I is going to be equal to 5. Well, 5 is not less than 5, so this loop breaks. We're done here. The problem with that is that we haven't found the item that we're looking for. So when we come down here and we ask the question, did we find it? Is found set to true? It is not. Found is still set to false. Our flag is still set to false because we haven't found what we were looking for. So we're going to print out a statement to that effect, that we didn't find it. That is the basis of how sequential search works. You might have to adapt it to fit the parameters of what you're being asked to do at any given time, but that is sort of a very basic version of a sequential search. Of course, if you have any questions with this exercise at all, please feel free to email me, bsimbeck@ccac.edu. And I would be more than happy to help you as best I can. Thank you for watching exercise 2 for week 11.